Alright, let's look at this one. We've got a mass, we have a velocity, we have a radius, and we have a mu. Coefficient of friction is the mu. So really what they're saying is, with the numbers we have, this one we're not going to use. We're going to calculate the v, the question mark is going to be v, to see if the mu and the radius and the mass, to see what the max velocity is, and then we'll compare it to the 27. So we're going 27, we want to know if we'll slide out of that curve or if it'll be safe. So we know, going around a curve, we have force gravity down, we have force normal up, and then we have force friction going towards the center of the circle. So a couple of things here. Let's go forces in the y direction equals 0, and force normal minus force gravity equals 0, which is going to tell us that the force normal equals force gravity. Force normal could equal mg as well, because that's just the definition of force gravity. Let's go to the sum of the forces. Sum of the forces in the x direction equals mv squared over r. We only have one force, and that's the force of friction, equals mv squared over r. Force of friction, we really have nowhere to go with that, but we do have a mu, so we should know by now that the force of friction equals mu force normal. And so I'm going to, everywhere I see force of friction, I'm going to replace it with mu force normal, and I'm going to get mv squared over r. Still kind of stuck, don't really have a lot of places to go. However, I can replace force normal with mg, mv squared over r. I'm going to give myself a little bit more room here. Boy, it's kind of small, isn't it? Alright, so let's solve for v. We'll get v all by itself, and I will get r mu mg, but I have to divide both sides by m, and we kind of talked about this today, equals v squared, which if I'm going to say v equals r mu times gravity, but I'm going to have to square root that. So let's plug that in and see what we get. Radius is 150. Mu is 0.4, just kind of small. Gravity, let's use 9.8 for fun. Throw that in the calculator. 150 times multiplied by 0.4 multiplied by 0.8. And then take the square root of the answer, and I get a velocity of 24.2 meters per second. So we can say, they asked, is it safe? I would say yes. It's, oh wait, 27 is the number up here. No, it is not safe. Well, I'm a little embarrassed right now. No, the best speed we could do with this coefficient of friction and radius, would be 24. So no, 27 is too fast. Slow down, people. All right. Bye-bye.